12.2, Fundamental Counting Principle and Factorials. In this lesson, we'll look at how to use the fundamental counting principle to find the size of a sample space and how to use factorials to find the size of a sample space. First, let's talk about the fundamental counting principle. It says that if an event can occur in m ways and a second event can occur in n ways, then the total number of possible ways that the events can occur together is m times n. So that just sounds like a lot of words, but let's look at it in context and it'll make a lot more sense. Here we have a context. The deli offers 2 kinds of bread, 2 meats, and 3 cheeses. If each customer only chooses one of each, how many different kinds of sandwiches can be made? So we already know how to solve this using our tree diagram, so let's do that first. For our 2 kinds of bread, let's go ahead and make that wheat. We'll make that one wheat and this one white over there. And for the 2 meats, let's make that some beef and some chicken. Beef and chicken. And then the cheeses, we don't have to get too fancy here. Cheese 1, cheese 2, cheese 3, maybe it's a cheddar and a provolone and a Swiss. Any of those would be good. Okay, so any of the breads you could have chosen either meat and then either of the 3 cheeses. So if we count up our sample space here, we find that we have 1, 2, 3 times 4, 12 possible sandwiches, right? Now, if we go back and use our fundamental counting principle, the FCP tells us that if you have the 2 kinds of bread, the 2 kinds of meat, and the 3 cheeses, all you have to do is take your 2 times 2 times 3, and you get the size of your sample space. 12 possible sandwiches. So doesn't that make life easier? Let's look at another situation. How many different ways can you order 4 DVDs on a shelf? Okay, so imagine you have a shelf and it has 4 spots. Let's give it 4 spots. In the first spot, you can choose any of the 4 DVDs, right? So you have 4 choices for the first spot. In the second spot, you've already put one on the shelf, so now you only have 3 DVDs to choose from. In the third spot, now you already have 2 on the shelf, you only have 2 to choose from. And in the last spot, you just put whichever one you're left with. So what we can do here is multiply then. Each number here represents the number of different ways an event can occur. So each one of these is like an M or an N, right? So there were 4 possible right here, there were 3 possible here, 2 possible here, 1, etc. So what we're doing is using the fundamental counting principle then and multiplying these all together. 4 times 3 is going to give us 12 times 2 is 24. So what that tells us is our sample space is 24. Therefore, there are 24 different ways to order those 4 DVDs on the shelf. Now what we've done here is actually a factorial. A factorial is written as n exclamation point, and it equals the product of all positive integers that are less than or equal to n. So what we just did there to determine the number of different organizations of DVDs on the shelf was 4. Factorial looks like just a very excited 4, but what it actually means is 4 times 3 times 2 times 1. We can do any other number factorial. For example, if you did 15 factorial, you would start with the 15 and you would just multiply on down all the numbers. It's going to be a pretty big number, right? All the way down till you get to 1. Times 4 times 3 times 2 times 1. Okay, so any number, no matter how big, can be factorial, but it does get to big numbers pretty quickly. Let's talk now about how you would simplify factorials. If you had operations with factorials, for example, 4 factorial times 3 factorial, what you're going to have to do is find out what 3 factorial is, which is going to be 3 times 2 times 1, and multiply that by what 4 factorial is, which is 4 times 3 times 2 times 1. Now obviously the multiplying by 1 doesn't change anything, so we can kind of take that out, and then we can split it up into groups here. 2 times 3 is 6. We know that 2 times 3 is already 6, times 4 is 24, and then we really just need to multiply the 4 times 24. So you can get to an answer pretty quickly there. Now if you're dividing, things can get a little bit even easier for you. Okay, so let me get this out of the way. For the dividing, what you want to do, if you have here, we have 12 factorial divided by 10 factorial. You want to list out all the factors before you start multiplying anything, because you can shortcut your work quite a bit here. Times 7 times 6 times 5 times 4 times 3 times 2 times 1. Woo! And then watch what I do here. Notice how 10 factorial is perfectly mirroring what we have above here with the 12 factorial. So think about, what's going to happen. If you have factors on the top, factors on the bottom, what we can do is this 10 factorial can basically cancel out all of this part of the 12 factorial above. So that all just cancels itself out, and all we really have to do is the 12 times 11. So whenever you're dividing, remember that you can make your life a lot easier by canceling out factors first. Okay, go ahead and do your try these number 1 through 4 and number 6.